Now the next part, as we discussed, after scanning for a victim and once a victim is found, is to actually go ahead and exploit the victim. So now what do you mean by exploit? Simply put, it is nothing but an exploit is nothing but a piece of code which provides access to a victim computer by utilizing some sort of a flaw in the logic of a program running on the victim computer. So what this might actually mean is that, let us suppose an FTP server is running on the victim computer and our worm has some sort of a code which can exploit the FTP server and go ahead and gain access on that computer. Now what do I mean by gaining access? By access I mean the ability to run commands or programs on that remote computer. Basically the ability to execute code on the remote computer. So this is what an exploit actually is. So once again summarizing, it's a piece of code which is going to exploit some sort of a vulnerability of a target service running on the victim computer. Once it exploits that service, it would have enough privileges to run commands or programs. We'll look into the details in later videos. Now network worms typically use what is called a remote exploit. What this actually means is an exploit which can be launched remotely and which gives some code running privileges on the victim. Of course this is required because the worm spreads across the network, so definitely it is going to target some sort of a remote service running on the victim computer. Now in order to make a worm, what worm authors actually do is find a suitable exploit, or basically a suitable remote exploit which they can use in their worm. Then they go ahead and try to understand that exploit. Now there are, I would say, hundreds of exploits which are posted on the internet for various vulnerable services on all these security sites. So normally what worm authors do is they go ahead, take some of these exploits which they could use in order to gain privileges on the remote computer and then try and understand the exploit. So there are two approaches to understanding an exploit. The first is the black box approach, in which you actually forget about what the exploit code actually does and then just look around how it's going to work. We'll talk about this in more detail in the programming exercise. To keep it simple here, I would just say writing a wrapper around the exploit itself and just using it as is without modification. That is what a black box approach of using an exploit could be called. A white box approach would be actually modifying the exploit code and then going ahead and using that. Now in order to modify the exploit code, you have to understand more about assembly language, little bit of reverse engineering, how to do disassembly and whatnot. So we'll reserve the white box approach for a later tutorial in which I'll talk about the various exploiting techniques such as buffer overflows, heap overflows and all that. To keep it simple, I'll use the black box approach here. And to be very frank, a worm author necessarily does not need to know how the exploit works right to the final byte of the exploit. If he has an understanding of what the exploit does and how that exploit can provide him some sort of an access to the remote machine, he could go about using that exploit to write a worm. So that is what we will try and do in this tutorial. Moving ahead. So once the worm uses an exploit to compromise the remote computer, of course it has to go ahead and clone itself. So when I say clone, it actually means getting a copy of the worm itself on that remote computer. Now how can this be done? There are actually various ways in which worms do that. TFTP is one. We all remember the blaster worm which exploited the RPC decom exploit on Windows systems, and this typically use the TFTP command on the Windows system to actually get a copy of the worm from the computer from where it actually attacked the victim. Alternatively, many worm authors use some sort of a central HTTP or an FTP server. I would say more of a farm of HTTP and FTP servers from where actually they could get the worm copy. Of course, you could also at times download the whole source code onto the remote computer and go ahead compiling. Linux worms could work like this, and some of them even do maybe. Another way of course could be to include the worm in the shellcode itself. Of course in this case the worm would have to be really very small in size. Anyway, there are many approaches to doing it. We'll typically talk about the TFTP approach and maybe the HTTP server approach, and I'll also give you a couple of pointers as to how we could go about implementing some of the other cloning or copying techniques. So once this copy has been downloaded onto the victim computer, the worm actually has to go ahead and run this copy, breathe life into its child, so that it can once again go ahead and exploiting other victims. So there are many ways to do it. And another thing which the worm has to ensure is that every time on startup, the worm code is executed. So to do all these things, normally what worms do is they add themselves either as a service, a daemon process, or add themselves to the registry entry for startup. There are many techniques. We'll look into it in the very end of this whole tutorial series as how you could go about making sure that your worm exists on that computer for a long time and gets executed every time on startup. So what happens next is basically the clone starts scanning once again. Once the worm brings its copy, its clone, onto the victim computer, it goes ahead and executes it. And this copy or this child starts finding more and more victims, and once it finds a victim, it goes ahead, exploits it, and gets a copy of itself on that, and so the cycle continues. So this is how the worm spreads infection. Now one thing as you notice is that worms are very aggressive in nature. That is, they go ahead and scan these thousands of IPs per second and try to spread. So actually this is very noisy, a lot of bandwidth is being consumed, a lot of system resources on the host computer is being consumed from where the worm is actually trying to spread. So there has to be ways to avoid detection, avoid getting detected from the antivirus. So you may need to hide the processes, hide the files, hide activity, maybe even delete some of the logs on the remote system to basically evade detection from where the worm actually came in, so that to make backtracing more tough. Or maybe even go ahead and install some sort of a custom rootkit to evade detection. So some of these stealth techniques I've just outlined here. We might discuss some of them in the coming videos. I would just like to summarize what we have done once again. So summarizing, the worm author goes ahead, creates the worm as we've discussed. The worm goes ahead and scans using random scans, sequential scans, subnet scans, etc., and trying to find a victim. Once a victim is found, it goes ahead and sends the exploit code which we talked about and gains access, or basically roots the victim, as they call it in hacker terminology. And then once this is done, it gets a copy of itself onto the remote computer and then executes this copy, which goes ahead and further scans for more victims, and thus the worm spreads. So now coming to what we will code in this section. So breaking it up, the first thing is of course the IP scanner code itself. Trying to go ahead and generate these IPs and finding out if those IPs are up and scanning them. Second is, given an exploit, having an understanding of the exploit to at least such an extent that we can use the exploit as part of the worm. Then we talk about some of the transportation techniques of the worm itself from the host from where it infected to the victim. In the end, we'll talk about a very simple framework which one could use to make worms, of course only for experimentation in a lab environment, whenever an exploit is released. So let's try and make a very generic framework where maybe we can just plug in a new exploit and we could go ahead and experiment with that worm in our lab environment. Once again, I'd like to stress that this tutorial is just to educate budding security enthusiasts about how worms work, because unless you really know and really have an hands-on experience of what it takes and how it feels to actually code a worm, you would never be able to understand how to design countermeasures in order to stop worms or mitigate them. So in the end, I would just request you not to use this knowledge for any malicious means. Also, at the end of this presentation, I'd like to point out that I've received a huge amount of response, a lot of appreciations from people from all over the world, and I'm really very happy about it, and I would carry on my good work provided of course people appreciate. So one thing which I've done is I've also started a forum where people can go ahead and post the latest topics which they want to talk about, because I have a set of topics which I've had in mind which I want to present, but maybe there are more interesting topics which I've overlooked, which could be more interesting for a wider, I would say, public and wider interest. So please go ahead to the forum and post whatever topic you want. The more number of people post on a topic, I might just take that topic up first and make a whole video series. With this, I'd like to end this presentation. see you in the next video where we talk about the scanning features of the worm. Thank you.